Right, welcome back to another Advent of Code problem. So let's start with reading the problem statement for today, and I think I'm gonna use Zig. I looked a bit over it, and I want to use again like a C-like programming language, mainly because it's 2D and we need for loops, and yeah, I wouldn't do like functional or weird stuff when it's a problem like this. So we arrive at a lava production facility. I guess this is another day, probably previous, like from last year. I don't remember it. Right, on a floating island. Oh yeah, I mean, I remember the floating island stuff. But we see like a reindeer. It has a hiking guide, and sadly the map has been scorched by lava, right? And we have a topographic map. I guess this is, no, it's Wikipedia. And this topographic map is our puzzle input. And what does it mean by topographic map is that we have the heights of each location, and they are from 0 to 9. So 0 is the lowest, 9 is the highest. And what we want to do with this topographic map is to figure out a good hiking trail, or I guess multiple hiking trails. And the hiking trail is gonna be um, going from 0 to 9, so from the lowest to the highest point, and it also has to be increasing by 1 each step. I think I'm not sure where it states that, but it's even gradual uphill slope. So it increases by height of exactly 1 at each step, right? And a trailhead is any position that starts one or more trailing hiking trails, and they are always going to have a position of 0, right? And here it explains that we can compute a score for each trailhead, and the score is how many nines can it reach. So it's not necessarily how many splits it can have, but it's more like, okay, if we start from this 0, how many nines can we encounter in the end? So it can even be like cycles and stuff. I guess you can even have cycles, I'm not sure. Well, you cannot really have cycles, that doesn't make sense, but you get the idea. It can be like multiple trailheads overlap and reach the same position. So you can think of them as multiple paths to the same location in a weird way, starting from different paths as well. So yeah. So I guess, yeah, what we have to do for today is figure out the total score. So that's just gonna be the sum of each trailhead. So yeah, it means that we have to parse this map into like a 2D array, probably. Then we have to find all the zeros, which are the starting positions. And honestly, I would just do like a brute force. I don't see like another solution to this one right now. Like just trying to go in each direction, and if we find a 1, then we know we have to find a 2, a 3, and so on. And if we find a 9, then it means that we increase the score of this trailhead. Right, so for instance, this one, you can see it has it reaches this point, then it can reach, I guess, another point. Right, so probably it makes sense, right? And what we have to be careful about is, you can see, not sure which example was it, but you can see that some trails split and meet back at some point in the on the trail. So you can have like different paths that lead to the same result. So yeah, we don't have to count the number of paths, we need to count the number of times we reach a different 9. Okay, so but I mean I'm not even sure that's gonna be a problem. I think that's just, you know, whatever. For part 1 at least, I'm not sure what part 2 could be, like number of different paths. That's gonna suck, but yeah, let's try to use Zig. Shouldn't make the problem more difficult because it has arrays and stuff like that. But no, the only issue, again, as all the other languages, is reading the input. No one knows how to write a function that reads the input. Anyway, so yeah, let's just uh, start with the first part, implementation. Right, so I just copy pasted this function that will probably read some input, but we'll have to refine it because right now it's just so void, right? And I guess Zig also has the same syntax as VLang with the return. So if it fails, it has this result type exclamation point, and yeah, that's the idea. So let's see in Day10. Yeah, it's Day10 already. That's pretty cool. Zig help. Okay, so we can compile a file by just I think we can. I thought you can just pass in the main Zig file and it works, but it doesn't. Zig run main Zig. Right, at least we can just run it. But it's funny that you cannot compile it. What? I guess you can build exe, build executable, build executable. Right. So we are gonna use build executable. Okay, so what is the problem here? We don't import std. Do we import? Wait, how do you even import stuff in this language? Sig docs. We need the documentation. Hello world. Probably we need to import std. Yeah. It was like JavaScript. So basically ask user what do we want to get from this function is I kind of want to get a list, like a 2D array of integers. So I might just say like this, but it doesn't like that. Okay, Zig array. I mean, they have like array type, but I'm curious if you can actually multi-dimensional arrays. I put it in the front. Okay. But can you have this kind of size? And also another good point, yeah, it is if we have a size for that thing. And because otherwise we could just use a vector type or whatever, which obviously much better, like vectors. Yeah, I mean, interesting. You actually have a length, so that's pretty good though. So if I say something like ask user, wait, did the LSP just die? Ask user. Okay, and we create a variable for input, right? And we have this input variable, but do you have length? Okay, it's probably gonna be const just to make it. Huh. So it is like U64 probably. So what I want to say is probably like length is a thing. Zig array length. Zig by example. Okay, let me just turn on this thing because otherwise everyone is gonna get flashbang. So I guess it's called len, but let's see. So here we create a reader. We don't need a writer, that's just whatever. Then we create, oh, and maybe U8. All right, maybe we can just use U8 for because it's numbers from 0 to 9 anyways. So we have a variable buffer, maybe 1024 characters. Then we read until delimiter or end of file, which is yeah, the meme itself. And then we have user input, return whatever. So here okay, I guess if we get an error, let's have a variable. Can I somehow next example pointers? I was thinking if I can have like the actual array thing, right? Like for instance, zig array append. Oh, but I don't care about the compile time. Add element. Wait, what the fuck? Hey, that's exactly. I mean, it's similar. It's new line. We mem copy and then lines append. Uh, that's not really it, but yeah. Oh, and here, yeah, it's right. I should probably just use a while loop because we want to read all the lines, right? We don't have an else. But how do I create this topographic map, right? That's what we need. So we need a map, and this map should be like this kind of U8. Right. It's sad that it really, yeah, because you kind of need. Okay, I know it has dynamic array, so let's just dynamic array, like that's Okay, that's not useful at all. Well, what would be more useful would be seeing the actual functions that are used for arrays. Like this is kind of not useful. Zig array functions. I mean, that's exactly what I was looking at, but Zig standard library. Okay, nice, perfect. This is what I wanted to find. So we should have something like, I mean, array list. That's a decent thing. Or maybe, I mean, I think array list would be like the easiest way to get it. Can I just see the source code? Nice. I mean, yeah. Okay, let's see. Zig array list. Perfect. So we can just create some kind of array list, and its type should actually be, it's pretty funny, it should be another array list. Or huh. Yeah, well, that's a good point. If I want to, okay, like let's say, I could actually day-init it, which is not what I want. Okay. And another one is the allocator. So how do you get like default allocator? Like, you can even have okay, this, okay. So undefined is more like a null. Yeah, but the problem with this buffer is that we need to know the size from the beginning, and we don't know that. So okay, let's use just std page allocator, right? And I can even have something like this in the beginning. Allocator is equal to std heap page allocator or something, just to okay, or like general purpose allocator. I mean, this one sounds more like it's supposed to work, right? Like I could just define it here. Oops. Hopefully I can define it outside. Right. And then I don't care that much. Okay, interesting. So then for the array list, it's in std, obviously. So we could even just define it like this, I guess. And here we need the allocator. Oops. Okay, and the idea here is, let's say I do something like list dot append, but I see it's with try. So I could even say try list append, and let's put a 0 or something. I just want to print something. It doesn't really matter what do we print, but okay, interesting. And what if here I say array list u8? Right, I can literally just return a type like that. So we get the input, and what's funny, it's that now we need the std out. Okay, perfect. So we get the std out, and we can just display stuff. Let's see if we can actually display, oh, zig std out format. Let's see how we can format some stuff. Did so you can put like these guys, and then in here I guess you can put your list of stuff. So for instance, if I put input, will it print the input? And let's say void. Will it compile? It says unused capture. So while I mean, can I just say, I don't know, I don't use it? Main is not marked pub. Okay, I have to say it's a pub function. Makes sense. Function with non-return type. I forgot to actually return the list. And I'm just gonna use run. Cannot format error. Aha. And here I can just try ask user. So we actually fail. Oh, nice. I should just press enter. A number, please. Okay. Array item 0, memory something, capacity is 8. I mean, it looks like a thing, right? But now what I'm curious about is having an array list of array lists of u8. But honestly, like at this point, I could even just have a this thing u8, right? Like just a vec inside of it. So would it be like 1, 2, 3 or something, or what? So zig array. I guess it's with a dot in front of it, or like this. So I have to say u8. And I guess the size is inferred or something. Not sure, let's see. So if I run this thing, array literal requires address operator to course type, so without it. Okay, and let me just create a temporary file for this input, so we have something to test with. So I can just paste in tmp. Okay, doesn't like that. What about just putting that? I mean, yeah, that's what I tried, because it says, oh, that. And here, array literal requires address of operator to course size type. So do I just need to add like the reference of this thing? Yeah, that's weird, because it wants. uh, okay, so there was something like slice, which maybe it's more important. So here it's a slice, right? That's how we get the slice. Okay, so we can put a star. Maybe star is like what we need here. So it's like pointer or something. Wait, do I need to put the... No. So for instance, here it's like this, then you generate a slice. Single item pointers plus a length. Oh, runtime known. I mean, yeah, I'll be honest, it doesn't make any sense. Okay, let's just use I just want to put pointer here. Like, is it really that hard to just do a pointer? It looks like this is a slice, right? As it says here, bool whatever. But how do I append a slice to this thing? Do I literally have to define it outside? Let's say we define a slice, and this is gonna be like this, and then we do what? Like something like this? No. expected type U8 and found that. I mean, here it needs the type T. Yeah, but look how weird it is, because here it says that slice is this kind of type, but then it literally converts to, like, what's the point of this thing? What if I just say it's like that? Interesting. I mean, you can even see here how it did something similar. Right, but I don't know what this function gets as argument. Maybe we can find it in the docs. It's not here. Zig docs std, like, come on. And it's this one, right? So it takes in exactly what I want, right? The U8 slice. So why doesn't it like this part? Expected type U8 found const whatever. It's like, yeah, whatever. Let's just try to take a line, which is probably a string, and let's try to convert it to this zig split string into U8 slice or whatever. Or is it already, maybe it is already what I need, right? What if I just say append line? Let's see the error. Oh, it was already that, but interesting that it has 0 0 here. 0 1 2 3 4 5. 0 1 2 5. And then, I mean, it looks a bit scuffed, honestly. It doesn't really look right. Maybe something broken with let's see, std out dot print we read this, and then I give it the line, let's say. Okay, try that try that stuff. I mean, it's a, whoa, it's a string. I mean, it looks like it reads it as it should. And then it's funny. It's somehow consuming that thing. Right? Yeah. Whoa, what? Yeah, see how strange it looks here? Okay, can I have something like this maybe? Oh my god, this is actually a joke. Wait, it's not gonna be a string anymore. What? This is so weird. Yeah, the length are... Uh-huh. But then if I just printed the line, then it was different here. That moment when... Okay. I mean, should we just say fuck it and do it like this? So we allocate some bytes. The size is gonna be line.length. And then what I'm gonna do... Do we have a for loop? I'm pretty sure we do have for loops. So I can have for... I want to iterate the... Yeah, like this. For line, and then we say character. Like, let's call it ch. But can I maybe get also the index or something? I think I know how to do that. I think I just have to say 0 dot dot and then ich, and then we can say something like bytes I is equal ch, and then I just append bytes. Right, and this one worked. For some weird reason, the other one didn't. Maybe it's because it gets overwritten or something. Fuck knows. But that's how things work. And here I guess we can subtract 0. Right, and if we subtract 0, we are gonna get the numbers themselves. Okay, fine, whatever. Whatever. So that's how we actually... That's what we actually have to do. Okay, whatever. I guess we have the input. Can I even say something like const a is equal to input 0? Is that a thing? Wait, but it's an array. Now the array list, let's see. pasted the array list. But then, okay, in array list, you know what's funny? We don't see the actual, like, where are the actual types? Get last. The fuck? Cannot I just say get 0? Really, it's gonna be get last. Oh, that's quite funny. So we can see the length, we can see the first item. Okay, then I'm disgusted by this one. Shit, the array lists are completely useless. That's why they don't have documentation. Okay, that's good to know. Then maybe vector. What is vector? Creates vectors. I guess vectors are more useful maybe. I know I saw here like arrays and vectors. Then, but yeah, that's pretty disgusting that you can only append to an array list. Like, what's even the point of it? Let's see, array list get index. And I forgot about Zig. You just say items. So I can say items 0. Uh-huh. Okay, that's better. You know, like, whatever, it makes sense. After all, like, array list is a structure, so you get a field, but having a function would be nicer. Anyway, so we can get the first line, right? Okay. Damn, that was insane, just parsing the input. So I guess now it's time to actually solve the problem. All right, so you can see how much time we waste with just parsing input with all of these languages. It's pretty, and I mean just parse input is so small compared to, like, for example, when I think in Rust I had to write more code for parsing the input yesterday, but since I already know the language, it's like much easier to do it because I knew step by step what to do. Here I have no idea. Like, okay, just do array list, or maybe we can even just convert it to pointer, like slice. In the end, that also makes sense to do, just to get rid of this array list, because that's annoying. So yeah, I'm curious, what if I say just list.items? What is list.items? Oh my god, that's perfect. Right, so that's what I want to return. That's perfect. Yeah, this looks much better. So I can even say 0 dot length, right? Much better. Yeah. So we get exactly like nice. Perfect. So actually, yeah, we got the map, right? Much cleaner if you have just slice. I'm not sure if I can, for example, free the array list. Will it break the entire thing? Like here you can see it says defer the init, but will it break? Yeah, it breaks it. Okay, interesting. So you cannot really like. That's why I don't know about the allocator stuff. Like manually freeing memory, like you just do C at that point. Okay, anyways, so let's try to actually solve the problem now. Right, so part one. So part one is gonna take in this U8 and it should just return U64 or something. Okay, return 0. Result is equal to part one map. And then we can just say part one result. Yeah, obviously here it's map. Wait, what? Expected. Huh. Maybe I don't know. Let's see what the compiler says. So I guess I have to put them in the reverse order. No. I have to put a comma, what? Wait. So when I look at the function definition, it's, I mean, it's a bit unintuitive. No, it's fine because variables are declared in the same way, so I didn't pay attention to that. Okay, yeah, so if it's the same as variables, I was confused for a second. Okay, so what should we do for part one is obviously let's try to find all the zeros, right? We try to find all the zeros and then so I'm gonna do like for loop, right? Like a 2D for loop over the entire thing, and then if we find the zero we have to do something. So I'm gonna say like var total is u64 equal to 0, and then we have for loop, and here we can say something like 0 to map dot length, and this is gonna be our row, and then a for loop from 0 to map row dot length, and this is gonna be our column, right? And now if map, I guess I have to put parentheses, or do I? Okay, if map row column is equal to 0. No, like I could, because it takes me like a few, like 30 minutes or something to get used to the syntax and the basics of a language. So I could use it like beforehand, but I think it would kind of ruin the experience, right? Like probably it's the interesting part is how easy is it to pick up one of these languages if you are like zero knowledge about it. So that's why I think it would kind of ruin the experience a bit. Okay, so we have if the map is 0, then let's just say total plus equals to 1. Let's just increase the total and let's see how many zeros do we have. So we have 9 zeros, right? 9 trailheads. Okay, we have 9 trailheads. So what should we do? Maybe I can have a function trailhead which takes in this map and it takes in the row and the column, right? And it should return how many 9s are available, right? And here we just put trailhead map row column, right? So clearly it's kind of like we kind of need some recursion because we'll have to check up, down, left, right, right? We have to look up, down, left, and right from the current position. And basically we need to find a number that's greater than our current number by 1, right? So that's what we have to do. And so that's why I think or maybe even trailhead just returns a list of positions, so it gives us all the possible destinations, right? So we can just say okay, it reached like these 9s, but look, some of them repeat, so in total instead of having 7 we just have 3 because only 3 of them are unique, right? Something like that. We could do that, and I think that's the easiest way to do it. And the other one is like what would be another option, right? Because yeah, that's what we kind of want to do. We just want to simulate it because even if you look at the puzzle input, it's small enough. I think it's small enough to just simulate going through the trail. I don't really see another way of solving this one. So that's why I think we just need to go up, down, left, right, and in the end return the positions of the 9s that we visited, Right. I think it makes sense because otherwise we would return what, right? So that's gonna be trailhead, and let's have a function called hike. Why not? And the idea of hike is that it's gonna take in this u8. It's gonna have a row and a column. Let's think. It's gonna have a row and a column, obviously, u64, column u64, and I think it should return a list of coordinates, right, that we found. But I don't think it's possible to have like a tuple. Close. It defined it like I mean, it makes sense, right? I can have a tuple u64 u64 because I kind of want here to return a list of like a slice of tuples, right? So then trailhead, what we need to do is const tuples is equal to hike map row and column, and for now let's just say we get the length, but we need to unique elements, right? We need to get only the unique elements, but for now let's just get the total length and see how the output would look like with all of them. So I could just say 2 like this or like this. I mean, it's like C. Okay. Okay, so what's the base case? All right, because we need the base case. If we do recursion, well, the base case is if map row column is equal to 9, then we need to return basically is this gonna work? Row column, that's pretty nice. I mean, it's like C again, just how you do, you know, an array of one item. Okay, and on the else case, it's gonna be more interesting. We have to go basically up, down, left, right, but we have to be careful with -1 because you know, we have u64s. Maybe that was a mistake. Maybe we should use i64s for the positions. In fact, maybe we should use i64s and the tuple as well, like whatever. Alright, so we have like i64s, and here we return the length, so should be fine. But what's on the else case, right? As I said, so let's have const directions. Well, I could say instead of tuple, position. Right, we just have position. well, whatever, it's fine. But direction is just gonna be for tuple array, and it's gonna have -1 0 0 yeah 0 1. Wait, what? It's the most random order. 0 -1 and 0 1. I think I need to put dots in. Yeah, perfect. So we are kind of close. We need to iterate for directions. We get a single direction. Function is bounded, or should I say like this, is bounded, and here we can pass position is going to be a tuple, and maybe I could send in width ES64. I64 doesn't really matter, right? I64, and it returns a boolean, right? So I have to say return. Oh, and that's gonna be interesting. To access the first field in this structure, how do I access it? Interesting. Oh, so just like this. Okay, so position 0, and so it's less than equal. Position 0 is strictly less, so I'm gonna have row and column. So a row should be less than height, obviously. 0 is less than equal than position 1, and position 1 is less than equal than width. I think that's okay. Pretty useful error message. Okay, so for direction in directions, we need something like a function. I'll be honest, the name, or like ivec2 is more useful. Function ivec2 add b ivec2, and it just returns ivec2. So I can say something like a0 plus b0, because I just want a function that adds these together, plus b1, and that's the easiest way to do it. So then here we can implement our thing. Interesting, maybe I should have asked here for a position though. Right, so now I can just put pause here, and here is gonna be, I said first item is gonna be row and the second one is gonna be column, so like this. But yeah, maybe it would make more sense to actually, like, instead of tuples, actually just use a structure, but whatever. Now we just started with tuples, could be fine. Let me just return an empty list here, or just break. And what happens if we run this thing? Okay, so here it's gonna complain, obviously. Row column. Wait, what? But why? Ah, because it's here. Found use. Oh, so it's use size. But I can do like I64 like this or something. No, wasn't it? Casting. So it's like as I64. Because I need the I64 values. Oh, what? Okay, that's not good. Like, I don't really care. Oh, don't really care that much. That we lose information because it's not gonna be that big, so it's fine. Oh, that's disgusting. Yeah, that's actually kind of annoying. Imagine I have to use int cast everywhere almost. Like, the fuck? How can you implement this one in a smarter way? Because I want... Huh. Type does not support array initialization syntax. Here, buddy. So it wants me to allocate it, probably. Alright, like axis alloc ivec2 1. and then axis 0 is equal to pose, and then I just return axis. Is that what you want? So it can just error out. Okay. Perfect. So here, when I do hike, I should do a try, and this thing can error. And here when this thing can error. Part 1 can error. Wow. Fuck. Who would have guessed? I see. So it's not returning anything. Okay. So we have to explicitly like do some recursion. Can I just have return empty? That's not a thing. It's annoying. Let me just do like this, and that's it. Just to get some output. Okay. Perfect. So what are we gonna do here? Well, as I said, here we are getting the direction. So I need to do something like const new position is IVEC2 add of position and dir. So this is going to give us a new position. And I can say you know what? Then that, yeah, that's annoying. I'm gonna have a function map get, because it's annoying to cast those things every time. And I'm gonna say position is an IVEC2, and this thing returns an U8. And what that thing is gonna do is just this call. Right? So then I can say map get map position, and that's that, right? I don't have to look at this ugly code again. Perfect. So now I can say if map get of map and position plus 1 is equal to map get new position, then that's when we want to go again. But I would also say is bounded new position, and then what? What if I send here the map itself? Because so I said height, right? So this is map length, and this one should be map 0 length. Not sure if I have to cast them. Right, and let me just say here return hike of map and new position. So this is not really gonna work. It's just gonna return the first one. I have to collect all of them. and then return. But let's see if this compiles, because I'm curious about compilation errors. Fuck. Okay, let's put the return here, and here I'm just going to break or something. Nice. So it still compiles even with these checks. Okay, perfect. So as I did here, I need to do something like this, and let's use array lists again, because it wasn't enough for the first time. Okay, so I'm gonna have array list of ivec2, right? And here I want to append many. Oh, I saw an example with append slice. So I can do list append slice. It's basically list append many. Append slice. So that should append. You know what I forgot? Const results. Let's try it. And then results. So yeah, and I think this, oh, right. This one also needs to be tried. Perfect. And here at the end, I just need to say list.items. Right, and this should actually this might just work, but I have to do unique items, right? So let's try to print the tuples. So I'm gonna say trailhead, this one, let's just format it really pretty. It's gonna be like a row and column, and we show the tuples. Right, let's see if oh, I forgot about the any here. Okay, so we get trailhead 02 gives us some points. Thread panic. Wait, so I forgot about less than. Nice, so we get some results. I forgot about the new line. Right, but I want to see if there are any duplicates. You can see 5, 4 and 5, 4 are reached, right? In the same way. Now it's interesting that there are so many, actually. But maybe it's just that there are so many paths, right, that go from, for example, from 0, because I copied this one, from 0 to, it looks like there are a lot of paths, right, that reach in the same place, I guess. But I mean, it's also quite weird how many there are. It reaches to 0. Yeah, I mean, maybe it is just that many. Who knows? Okay, and the idea now is to just keep the unique tuples here. So these are the results, right, of our hike, and I want to keep only the unique ones. So can Zig do that by default? Do we have something like a set? set. I mean, I see the word set, buffer set, enum set. I mean, there is hash map. What is buff set? Okay, zig hash set, because that's what I need. Hash map. Hash map. I mean, I don't really care. Like, if we can just use hash map, it is what it is. I'm just using a hash map. But why isn't there a hash set? That's weird. Whatever, let's use a hash map. So I'm gonna do auto hash map. So here, when we are trying to results, all right, and I guess the key is gonna be an IVEC2, and whatever is gonna be a boolean. We don't really care. And here I'm gonna use the allocator. I'm not even gonna bother to free anything. We just leak as much memory as we can. Let's see if it can handle it. So for results, right, we get one of the endings, like one of the nines. So here I'm gonna map put result and true, like whatever. Let's call it dupes because it's used to check for duplicates. Okay, and here what if I return just dupes.count or something? What if I print the dupes? Well, it's called length or something. Let's see. Maybe it's like length. Oh, it's a function. It's a function. Okay, makes sense. 36. Nice. So it's actually 36. Okay, and for example, next develop. What would happen if we try to get the input for day 10, and here we switcheroo with day 10 input 531. Hopefully it's not like I mean, you know, I haven't showed that part when it yeah, it worked. So when I failed, it was working on the puzzle input, but I had like an off by one error or something. Okay, so let's try to read part 2 now. Okay, so the reindeer spends a few minutes reviewing your hiking trail, and then it realizes something, obviously, and it returns with a slightly charred piece of paper. The paper describes a second way to measure a trailhead called its rating. And the rating is the number of distinct hiking trails which begin at that trailhead. Number of distinct, okay, so it's exactly what I said in the beginning. It's the number of, so the above example has a single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails. And this has 13. Wait, is this just doing part 1 without the unique? Is that it? So if I say rating, is it just the results length? I mean, shouldn't it maybe have been the other way around? I don't know. Maybe there is a solution for how do you call it, for part 1 that doesn't involve simulating the result 1, result 2. Let's see. Like, it's weird. Yeah, it's just that. Funny. So for part 2 we just actually already solved it earlier when I said okay, for the trailheads we need to do unique, and initially we weren't doing unique just to see how many paths we actually have because I was curious, and actually that thing was the answer for part 2, so that's kind of funny. Honestly, wait, what did I say I was expecting for part 2? Nice. So I guess I said that for part 2 I was expecting to, yeah, be something like this. I was maybe thinking it's gonna be a bit different, like you need to do some multiple, but in the end it was still just how many paths you can have from the beginning to the end. So yeah, how many distinct hiking trails, which, yeah, part 2 was so much, like, I'm just curious. Cannot I see my stats? Yeah, I was curious how much time it took to solve part 2 basically, because like after part 1, because it was probably like 10 seconds just copy pasting the function and removing this part, right? So that's, yeah, it's interesting. Part 2 was much easier than the first part. But yeah, that's everything for today. Maybe what I have to do, what's left to do with Zig is the make file, right? And we can just copy paste a make file from another language and then Zig build executable, and the Zig. Does Zig build have a -o? Surely it has, right? Oh, it's target, or, dude, come on. Sure. I mean, I could just try main zig dash o main, like, okay, zig build x out path. Whatever, let's not worry about it. So the command is gonna be like this: zig build, right, exactly what we have here, and then we just copy main into day10. So I just need this make file, because now we can just run make, and then then day10, right? And that's because I want to add it to our Nix flake, and basically just copy paste this one that I had for Rust, and here we need Zig as a dependency, and then we can just add it to the script, right? Because I want to have like each day, like a script for each day. Hoof it. All right, so now if we run nix run AoC, oh, not in this folder, but in the main one, which has the input files. Whoops. I guess I have to do the usual stuff, like Nix not adding the files. Okay, zig git get, zig git ignore. Ah, it's completely useless. Okay. Nice. This is also annoying. I don't know why all languages, like Rust. There was also another one which was being annoying with Nix, but yeah, as I said, that's useless. Let me just see if I go day10 and run make, what does it generate? So main and main.o. Right, but it's interesting. Right, so it complains, it says that access denied. Pretty funny. So what I had to do for VLang, which is also another annoying language to build on Nix, was to set the home. Oh, so it has the same problem. I don't know what the problem is, to be honest. I mean, it's the same, like my language stack also has the same thing, but at least I can explain why stack home is a thing, right? So stack home is the installation directory of stack itself. So, but what I'm curious about is why does VLang and Zig need this home variable? So they do something in home folder. I wonder what they are doing there. Right, and yeah, you can see that it prints the results for each day. Obviously, my language is probably one of the slower ones. You can see it takes some time. Then Prolog, obviously, probably is the slowest one. And I think JavaScript. I think I did something wrong with the JavaScript one. Probably I can do some optimizations. like I was actually I was thinking about so if I do pm start, so it was day 6, right? So I think there is some optimization I can do. Wow, it's moving annoyingly. Let me just, probably there is some optimization I can do with this one. Like this first part, it's fine, right? That's how it's supposed to work. But for the second part, it's checking all of these points. I think I should only check the points that are in the original path, because otherwise there's no point in checking if I put an obstacle here. Like it's not going to influence the original trajectory of the guard. So I might as well just put the obstacles only on the places that I visited in the first part, right? So I think that's the optimization I can do, because it's a bit slow for the second part, but yeah, then it's pretty good. Yeah, actually it was easier than I expected to work with Zig, which is good. But my yeah, let's say my only problem right now is that you still have to do manual memory management, or maybe it depends. Maybe depending on what allocator you are using, you don't have to do that. Like let's say for example you create like a arena allocator, and then you just free the entire allocator at the end, and you're like, okay, I don't care that I leaked memory into it, I just free the entire thing at the end, or something like that. But I mean, the point is to free the memory as soon as possible though, but uh, because otherwise it's gonna stack up if you don't free it. Like here for instance, the memory, yeah, obviously it's freed once the execution reaches the end of main, but imagine I run this function 1,000,000 times, right? So that's the idea with with freeing the memory. Imagine I run it like 1,000,000 times. Wouldn't be very cool, because it means 1,000,000 allocations, which not really possible, but yeah, that's why I say at least that's how it's supposed to work. You have to free the memory as soon as you can. So again, like not really sure why. I mean, I guess I see why you would like to use Zig instead of C, because it has nicer syntax, a bunch, like the tries are so nice. Um, Even this annoying stuff with you having to explicitly cast all the types if you want to switch between usize and signed and unsigned, that's also fair, because at least you are responsible for the, like, it's not done automatically, let's say. But again, like after programming for a while in C, you already start to have these data structures like array list. I already have it in my ds.h, right? Maybe we can do C like next time, or not necessarily tomorrow, but at some point when it's gonna become harder. And you'll see that I already have the array list data structure, or I mean, yeah, it's funny, I don't have a hash set as well. That's quite funny, but I mean, hash maps, like all of this stuff, you begin to build them up in like small functions, right? So, but yeah, I mean, I see the nice stuff about the result type. That's, I guess that's, the one of the best features that Rust popularized, let's say, the result type. So that one is a pretty good one. But yeah, all in all, it was a pretty short solution. it was also an easier day, so yeah. But I guess that's it for today, and we'll see with the next one. So see you.